Hi everyone, so welcome back to my channel Mathematic Girls Swati 3226. So this is a video on determinant. This is a topic for class 12, as you all know. So this is a very important topic, determinant, and I have taken just one very important question, and that is you have to prove determinant of minus a square ab ac, that is in the first row. In the second row we have ba minus b square bc. In the third row we have ca cb minus c square. That is equal to 4a square b square c square. So this is what we are supposed to prove. Okay. So let us start with the proof. So let us first write down what do we have on the LHS. LHS here, of course, is the left hand side. So there are basically two ways to write down the determinant. Either if you want, you can write down determinant of a like this, or if you want, you can directly write down determinant of a like this, because this is a symbol of determinant. So I'm going to write down directly like this. So just a straight line and then the values. So the first row, okay, that we call as the first row. So in the first row, we have minus a square, then AB, and then AC. In the second row, we have BA, then minus B square, and then BC. In the third row, we have CA, CB, and then minus C square. So this is the determinant that we have. Now we are going to simplify this because we have to bring 4a square, b square, c square. So the very first thing that I'm going to do here is I'm going to take the variable a, b, and c common from row 1, row 2, and row 3. So if you want, you can write down the same. Taking a, b, and c common from row 1, that we also denote as R1, that is row 1, row 2, that is R2, and row 3. Okay. So if I take a common from R1, that means row 1, of course, a is outside. And in the first row, because a is outside, so we have only minus a because 1a is already outside. The second, we have b only because a is outside. And the third, we have only c. Now, of course, I have taken b also common. That is from row 2. So that b is outside here. And then in the second row, we have b outside, so only a. Then here, because b is outside, so minus b. And then here b is outside, so c. In the third row, or like from the third row, we have taken c common. So c will come here. And from here, only a. And then only b. And then only minus c. So now we have this, but still we have not reached to the correct answer. The RH is basically the right hand side. So we will simplify this further. Now what I'll do, I will take again A, B, and C common. But this time it is little different than the previous one. So here taking A, B, okay, this is comma, remember, not A1, B1. Taking A, B, and C common from columns. Okay, remember, this is called row and this is called column. Okay, so this is row and this is column. Okay. So now I'm going to take common A, B, and C from columns. Okay, all the three columns, that is C1, that is column 1, C2, and C3. So if I take A, B, C is already outside. Now I'm taking A common from first column, that means this column. So if I take A common, in the first column inside the determinant, we have minus 1. And then 1 because a is outside. So it is just minus 1, then 1, and then 1. Now b I'm taking common from column 2. This is column 2. So if I take this b common, so I'll be, I'll leave with only 1, minus 1, and then 1 because b is outside. And now from the third column, that is this column, I'm taking c common. So we are going to have 1, 1, and minus 1. So this is what we have inside the determinant. Now outside the determinant, we have ABC into ABC, that is same as, let me write down. So we know that A into A is A square, right? So here we have ABC times ABC. That is absolutely ABC whole square. Now remember, ABC whole square, it simply tells you that whatever we have, like whatever variable we have inside the bracket, the power or the exponent will come on each of the variables. So this will become a square, this is b square, and this is c square. So we have a square, b square, c square outside the determinant. And now inside determinant, we have in the first row minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. So here we are going to use some operations. Okay, so we are going to use some operations. So that is, I'm first going to do row 2. Okay, so these are basically called row operation, or if you want, you can also use column operation. But here I'm going to use row operation. So R2, that means second row, I'm going to do R2 plus R1. See, remember, if you're getting confused, this one is R1, this one is R2, row 1, row 2, and row 3. So what is the row operation that I'm applying here? And that is R2 as R2 plus R1. It simply means that the other rows you have to write down as it is. So it is minus 1, 1, 1 as it is. Row 3, we are not doing anything. So it is same 1, 1, minus 1. And row 2, we are applying the operations, and that we are doing as R2 plus R1. That means this plus this. So 1 plus minus 1, that is of course 1 minus 1, that is 0. Minus 1 plus 1, that is 0. And 1 plus 1, that is 2. Okay, so this is the row operation that we have applied. Again, another step, I'm going to apply the row operation once again. So this time I'm going to use R3, row 3 as R3 plus R1. So what this will become? This will simply become row 1 as it is, minus 1, 1, 1. Row 2 as it is, 0, 0, 2. And row 3 is row 3 plus row 1. That means this plus this. So 1 minus 1, 0. 1 plus 1, 2. And then minus 1 plus 1 is 0. Now you can see that this is now very simple to solve. So this determinant we can easily solve. So I'm going to expand this along first column. Okay, so if you want, you can also write down this thing, because whenever we solve the determinant, we always write down along which row or along which column are we expanding it. So by expanding the determinant, or by expanding it along first column. So there is a rule for this as well, and that is you have to take the first entry, which is minus 1, because you are applying, you are expanding it along the first column. So minus 1, so you have to leave this column and this row. You have to write down the next thing inside the determinant. So 0, 2, 2, 0. And now there is a rule, okay, because this is inside the bracket, because this is another part, so I'm writing it inside the bracket. Now the next I have to go to 0, okay. So because the next entry is 0 here. So remember that when we solve the determinant, the signs are alternative, okay. So this was plus because this is minus 1 already, so it was plus basically. Next you have to give the alternate sign, that is minus. So it is minus 0 times something, okay. Again 0 times meaning you have to remove this row and this column. So the remaining is 1, 1, 2, 0. But I want to tell you that here, it is not required to write down, because it is ultimately 0 is getting multiplied with that, right? And 0 multiplied by anything is 0. So if you want, you can just write down your minus 0. And then of course, again, the next step is plus 0. So you don't have to write down the inside part of the determinant, because that is ultimately going to be 0. So we are here. Let us simplify this now. So this is a square, b square, c square. Inside the bracket, we have this minus 0 plus 0, no use now, so you can skip it. Now here, if you simplify this, this is minus 1. 0 times 0 is 0. This is how we solve the determinant. Remember, if you are solving a determinant a, b, c, d, you simply have to multiply a times d and then minus b times c. So using this formula, of course, this will become 0 times 0 minus 2 times 2. And now if you simplify this, this will become a square, b square, c square, and then times, this is minus 1, right? This is 0 minus 4, Now, if you simplify this, this is a square b square c square times this is -1, and then 0 minus 4 is -4, so times -4. And now if you simplify this, it is a square b square c square -1 into -4 is of course 4, because we know that minus into minus is plus. So our final answer is 4a square b square c square, and that is nothing but our RHS. Hence, proved. So this was a very important question. I have seen this question, like in a lot of exams. So that is why I thought of solving this particular question for you. So I hope this video was helpful and you have understood how to solve this particular question. So keep supporting the channel. Thank you so much for watching.